Hello everyone and welcome to my YouTube channel. In this lection we are going to talk about how to convert a point for Cartesian coordinates to polar coordinates. So we need to consider four cases. First case, when we have the point in the first quadrant of the Cartesian plane. In this case, x is positive and y is also positive. The second case is when we have the point in the second quadrant of the Cartesian plane, and here x is negative and y is positive. The third case is when we have the point in the third quadrant of the plane. In this case, x is negative and y is negative also. And the fourth case is when we have the point in the fourth quadrant of the plane. In this case, x is positive and y is negative. Remember that we want to transform the point x, y into the point r, theta, where r is positive and theta is between 0 and 2 pi. So let's continue. Well, we are going to analyze the first quadrant where x is positive and y is also positive. As you can see, we can draw a little triangle here around the point. This triangle is a right triangle because it has a right angle here. So this blue line represents the radius and theta represents the angle between the x-axis and the radius. So if we want to calculate the value of r, we need to apply the Pythagorean theorem, which states that the square of the length of the hypotenuse is equal to the sum of the square of the lengths of the legs. So if we apply the Pythagorean theorem here to this triangle, we have r squared is equal to x squared plus y squared. If you take a square root on both sides, we have a square root of r squared equal to a square root of x squared plus y squared. If we simplify, we have that r is equal to a square root of x squared plus y squared. And we can use this formula to calculate the value of r. Now, to calculate the value of theta, we can apply the tangent of theta. By definition, the tangent is the opposite leg over the adjacent leg. So we have tangent of theta equal to y over x. If we apply inverse tangent or arctangent on both sides, we obtain that theta is equal to inverse tangent of y over x. And with this formula, we can obtain the value of the angle theta. Remember that we are consider r positive and theta between 0 and 2 pi. Let's see an example. Consider the point 2, 2. It's clear that the point 2, 2 is in the first quadrant of the plane. So let's calculate the value of r. So we can apply the formula r equal to a square root of x squared plus y squared. Substituting the value of x and y in this formula, we obtain that r is equal to the square root of 2 squared plus 2 squared. Solving these operations, we obtain that r is equal to the square root of 4 plus 4, which is r equal to a square root of 8. If we simplify this, we obtain that r is equal to 2 square root of 2. Now let's calculate the value of the angle theta. So we can apply the formula theta equal to inverse tangent of y over x. Substituting the value of y and x, we have theta equal to inverse tangent of 2 over 2. If we simplify this, we obtain theta equal to inverse tangent of 1, which is theta equal to pi over 4, or theta equal to 45 degrees. So in conclusion, we have that the point 2, 2 is equal to 2 square root of 2, pi over 4, or 2 square root of 2, 45 degrees. So it was my pleasure to share with you this knowledge, and see you in the next class.